ThreeStudio is a diverse and advanced framework for creating 3D content. It is capable of converting text prompts, single images, and few short images into 3D models using 2D text to image generation LLMs. ThreeStudio features various custom extensions including 4D FY for 4D content creation and Dreamcraft 3D for high quality image to 3D conversions. In this video, I'm going to show you how you can get it installed locally on your Linux system or in the Collab. For this example, I'm going to use the Google Collab, and these commands which I'm going to show you, you can use it on any Linux system including the Ubuntu. Okay, so first thing you need to do is to make sure that you have changed the runtime of your Collab to T4 GPU, and this is a free Collab account I'm using. And then let's check the NVIDIA SMI. Let's run it just to make sure NVIDIA's GPU cards are there, because that is what we would need, and that is fine. Now in the next step we need to clone the repo. Let's run it, and this is the repo which I just showed you, and I'll drop the link in video's description. It is cloning it, cloning is done, and now in the next step let's cd to the directory. There you go. Okay, now we are in the ThreeStudio directory. It's time to install some of the prerequisites, and there are a lot of them. Let me run it, and all of them are required. So let's wait for all of them to get downloaded and installed. Shouldn't take too long. As you can see, it is almost done. It is at the last one to install Plotly, which we will be using for mesh visualization. Hopefully it will be able to cope with my resources on this Collab. Almost done. Okay, and it is done. Now in this step, the next one, we are going to build some of the dependencies, and this is where it takes a bit of a time. So the previous step took around 2 minutes. This is going to take a bit longer because it has to build all of these. So let's wait for it to finish. Won't take too long. So as you can see, it is still building, and it has already been running for the last 14 minutes, as you can see at the bottom of the Collab. So let's wait for it to finish. So it took almost 25 minutes to complete, but at last it's done. As you can see, all the dependencies are built now. In the next step, let's log into Hugging Face, because that is where we need to download the diffusion model in order to run this. Click on this, and it is going to ask us for our Hugging Face token. In order to get Hugging Face token, go to Hugging Face website, log in with your email, and then at the top right, click on your profile image, and then click on settings, and then on the left hand side, access token. Grab this access token from here, go back to the Collab, and then paste it here. That's done. Press enter, and then just press Y, and that's done. Awesome. Okay, now in the next step, let's set our prompt, which could be any text you want to create image from. So I'm just asking it that a zoomed out DSLR photo of a Santa Claus sitting with gifts in North Pole. It's a Christmas time. Today will be the Christmas Eve shortly here in Sydney, Australia. So let's go with the Christmas spirit. That's done. And now let's run our model. Now what is happening in this model is that we are using Dream Fusion model, as you can see from here, and we are using it with Deep Fluid IF or if guidance. Deep Fluid consists of a frozen text encoder and 3 cascaded pixel diffusion modules, or in other words, Deep Fluid if has a base model, that creates 64 by 64 pixel images based on text prompts, and 2 super resolution models. And each of those super resolution models, they are designed to generate images with increasing resolution, which is 256 by 256 pixel and 1024 by 1024 pixel. And then there are few hyperparameters we are setting with our prompt. So let's run it. Let's wait for it to come back, and once it comes back, then we will use IPython to display the image. It is installing, and that is hopefully done. Okay, so I need to request access to this model before I could use it, and pass a token having permission to this repository. Okay, let me see. So let's click on this one, and I just need to go down. I hopefully, where is the access? Agree and access repo. Okay, I need to fill it out. Let me fill it out. So I have just said personal and nothing other publication. So I'll just click. Okay, what the heck is this? So I just pasted NA here. Now let's see. Okay, so this is done. Hopefully now it will be able to give me the access. So now let me rerun this. Because I already have logged in above, as you saw earlier. Okay, now let's wait for it to finish. And you can see that this time it is downloading the model, which is around under 8 gig. So let's wait for it to finish. And you can see that model is downloaded and it is generating the 3D content. Let's wait for it to come back. And you can see that here it is building it with diffusion PyTorch model running along. It will take a bit of a time, so let's wait. And now it is loading the pipeline components. Hope so, it won't be long now. Okay guys, as you can see that it is still running even after 30 minutes, almost 30 minutes, and I'm not sure how long would it go. I think it will take plenty of time because I'm running it on one GPU and I don't have much grunt on this machine. So maybe the performance will improve if I'm using a beefy GPU, which I don't have at the moment. Anyway, so this was sort of the last step. After this, the video will be rendered by using these steps, and then that's about it, and in the MP4 format. And I'll drop the link to this Collab so that if you have any beefy system, then you could try it out. But I won't suggest doing it on this Google Collab with the free version because it takes a lot of time. As you can already see, it's been over an hour and I have been still running it. Anyway, having said that, really good project. A lot of other information is present on their GitHub repo, where you can see some of the online demos and how it works with animate, Gaussian splatting, MB mesh fitting, and a lot of other stuff. And then there are some installation instructions if you want to do it in the virtual environment on your Ubuntu system, as you can see here. But again, as we have already seen, you would need a good beefy system in order to run it properly. So that's it guys, I hope that you enjoyed it. If you have any questions or if thoughts, share them in the comments. And if you like the content, please consider subscribing to the channel. Thank you very much.